previously made a video on limits, so here's limits part 2. This video is going to cover harder problems and a technique called L'Hopital's rule. So here's L'Hopital's rule. Say you have the limit, the lim x approaches infinity, and your expression is x cubed over pi to the power x. If we try to use direct substitution and plug in infinity, we get infinity cubed over pi to the power infinity. This just simplifies to infinity over infinity. What's infinity over infinity? Is it 0? Is it 1? Is it infinity? This is what we call an indeterminate. 0 over 0 is also another indeterminate. Let's rewind a little. So here we have our limit, and we're going to use L'Hopital's rule. So what L'Hopital's rule says is, so you have the limit lim x approaches c, then some function f of x over g of x. And if we use direct substitution, f of c over g of c, this becomes an indeterminate, infinity over infinity or 0 over 0. So how would we solve this? Using L'Hopital's rule, this is just equal to same limit, lim x approaches c, but we take the derivative of the denominator and numerator separately. So f prime x over g prime x. This prime notation just means derivative. Okay, so here we have our limit. We can see that if we plug in 0, sine 0 over 0 is just 0 over 0, and that's indeterminate. So we have to use L'Hopital's rule again. Differentiating the numerator gives us cosine of x. Differentiating the denominator gives us 1. Now we can use direct substitution, and we can get cosine 0 over 1, which is equal to 1 over 1, which is equal to 1. Now here we see that if we plug in infinity, this does not end up well. Infinity squared plus infinity times 3 minus 2, that's just infinity, over e to the power infinity, which is just infinity. So we'll just get infinity over infinity. That's not very good, so let's use L'Hopital's rule. Let's differentiate the numerator. In my differentiation video, we discussed breaking this up into monomials, so let's do that again. Differentiating x squared, we get 2x. Differentiating 3x, we get plus 3, and derivative of any constant is just 0, so we can do minus 0 over e to the power x. You can see that if we differentiate e to the power x, we'll get e to the power x. I discussed this in my why is Euler's number so important video. Now if we plug in infinity, we'll get 2 times infinity plus 3 over e to the power infinity. That's just infinity over infinity. So we have to do this again. Differentiating the numerator, we get 2 plus, well, the derivative of any constant is again just 0, over e to the power x. And this just equal to 2 over e to the power x. Now we can plug in infinity. We get 2 over infinity, which is just equal to 0. Okay, so here we have our limit, x approaches 0, sine 7x over 7x. Again, if we use direct substitution, sine 0 over 0 is just 0 over 0. So we have to use L'Hopital's rule again. Differentiating sine 7x gives us 7 times cosine of 7x. Differentiating 7x gives us 7. And we can simplify this. We can see that the 7 and 7 cancel out, so we just get cosine of 7x. Now we can plug in 0. We get cosine of 7 times 0, which is just cosine of 0, which is equal to 1.